Hello everyone, my name is Ankush. I am a data science and business analytics intern at the Sparks Foundation. This is my first task of my internship and the task is to predict the percentage of a student based on number of study hours. Having two variables present on our dataset, we apply simple linear regression in our dataset. At first, we are importing all the packages that is NumPy, Pandas and Matplotlib. Next task is to read data from remote link. For printing top 10 rows, I use dataset.head under parenthesis 10. For seeing how many rows and how many columns are present in our dataset, I use print under parenthesis dataset.shape. Here 25 rows and 2 columns are present in our remote dataset. Dataset.describe describes all the data like mean, maximum and minimum values of the dataset, etc. Dataset info works same as dataset.describe. Here we can see there are two columns, that is hours and scores. In hours attributes, values are in float data types and 25 non-null values are present. In percentage columns, values are in integer type variables and 25 non-null values are present. For plotting the graph, we have two attributes, that is hours studied and percentage score. We can see there is a scatter plot between the hours studied and percentage score. After plotting the data points, we can clearly see that there is a positive linear relationship between the hours studied with the percentage of hour as students studied. For preparing the data, we divide the data into attributes, inputs and labels, outputs, and we split the data into training and testing sets. For training the data, we use linear regression. Training means to learn from the training datasets. Then we plot the regression line. It means the line that completely fits the data. After that, predictions can be made with the testing data. For that, we use regression.predict. Then we compare in between the actual with the predicted values of data. Now we can test with our own data to test how accurate our model gives the result. Our final step is to evaluate the performance of our model or algorithm. In this case, we use mean absolute error and mean square error. Our mean absolute error is 4.183 and mean squared error is 21.598. Thank you.